Hello everybody, in this video we'll be comparing rates of diffusion of different gases. At the end of this lesson, you should be able to state that diffusion is affected by relative molecular mass as well as temperature, calculate the relative molecular mass of different gases, as well as compare the diffusion rate of different gases. So, in the previous lessons, we've learned that kinetic energy of particles is actually directly related to the temperature of the particles. The higher the temperature, the higher the kinetic energy. Kinetic energy has a formula, right? Kinetic energy equals to half mv squared. So what does this half mv squared stand for? M stands for mass and SV stands for speed. Now, speed is actually the speed of the diffusion. So if the speed is higher, the diffusion is faster. So we can see using this equation that if kinetic energy is higher, the speed is higher. And if the mass of the particle is higher, the speed is actually lower. So it is very important for us to be able to calculate the relative molecular masses of gases. So let's practice 3 examples over here, right? You need your periodic table for this. Now, oxygen. The first thing we need to do is to actually determine the formula of oxygen. And oxygen is O2. Using the periodic table, we know that oxygen, one atom of oxygen is 16. Now, in O2, we have 2 oxygen atoms. So this is 2 times 16 equals to 32. Right? What about ammonia? Now, ammonia's formula, we must remember, is NH3. NH3 means that in each molecule of ammonia, there is 1 nitrogen atom and 3 hydrogen atoms. So, nitrogen, if you look at the periodic table, is 14. And then, hydrogen, there's 3 of them. So, it is 3 times 1. So, ammonia is 17. Carbon dioxide, right? The name carbon is C. Di means 2, oxide. So 2 oxygen, CO2. If you look at the periodic table, we have 1 carbon and 2 times oxygen, which is 16. And when you calculate this, this is 44. Now, looking at the relative molecular masses of the different gases, we can tell that carbon dioxide is the heaviest at 44, while ammonia is the lightest at 17. So we need to compare the rate of diffusions of different gases. So comparing ammonia and hydrogen chloride. So how do we do this? We need to first determine the relative molecular mass of ammonia as well as the relative molecular mass of hydrogen chloride. Just now, we have determined that the relative molecular mass of ammonia was 17. What about hydrogen chloride? Hydrogen chloride is HCl. And if you look at your periodic table, HCl has a relative molecular mass of 1 plus 35.5. And that will be 36.5. Now, ammonia 17, hydrogen chloride 36.5. So which gas will diffuse faster? So if you imagine a very heavy person as well as a very light person, the light person would run really fast as compared to the heavier person. So over here, ammonia will diffuse faster because it has a lower relative molecular mass. While hydrogen chloride will diffuse slower because it has a much higher relative molecular mass. It's heavier. Right? Let's look at one more example. Sulfur dioxide and hydrogen. So sulfur dioxide is sulfur dioxide, SO2. And if you look at our periodic table, this will be 32 plus 16 times 2. And this will give me 64. As compared to hydrogen, hydrogen has a formula of H2, which is just 2 times 1 equals 2. So as you can see over here, hydrogen has a relative molecular mass of 2, while sulfur dioxide has a relative molecular mass of 64, which is much higher than hydrogen. So hydrogen will be much faster than sulfur dioxide. So now we can see how we can use relative molecular mass, right, to compare the diffusion rates of different gases. So please practice and hope you can understand this better. Bye.